All right, let's take a look at number 6, solving exponential equations section. It says, looks like we got another model, by the way. Suppose the population of a colony of bacteria increases exponentially. Um, so right there, right before we even finish this problem, it's telling us we're growing exponentially, which means we're growing at a fixed percent, and it's increasing, which tells us that we have a growth model that we're going to be working with here. So it's y equals a times 1 plus r to the t power. Okay. As we read the rest of the problem, let's see if we can identify and pick out some of these other values, and then we'll plug them in and solve from there. So we have, let's see, at the start of an experiment, there were 6,000 bacteria. So that's going to be our initial amount, 6,000, let's say. And 1 hour later, the population has increased to 6,400. Careful, that's not y yet. Okay. How long will, there's our question, how long will it take for the population to reach 10,000? There's our y, there's our future amount, 10,000. And then we want to figure out how long. So that's our unknown. Round your answer to the nearest hour. Okay. So we actually aren't given an r in this one. But they gave us enough information to figure it out. We can find the percent change over the course of 1 hour here. And to do that, we just need to take, the change that happened. So from 6,000 to 6,400, that's a change of 400 bacteria, right? And then we'll just say, well, how much did that change then from the initial amount? 400 out of 6,000 is going to be about 0.0666667. So it's repeating. Or as a fraction, 1/5, and that's kind of tricky there to work with. We almost always plug that in as a decimal, and you could just do 0.0666, repeating, or you can do the 1/15. That is our decimal, right? So that's what I'm going to put it in as, just to make sure I don't have any rounding issues. But it's 0.066 repeating, which is equivalent to 1/15 as our decimal, just as written as a fraction. Okay, so there we go. We found the r, we got the y, we got the a. Well, the only thing we need is t. Let's plug in everything and see if we can come up with that. So we got 10,000 here is equal to a, which is 6,000 times 1 plus our rate of 1/15. I'll put that up to the t power. And there's some simplifying we can do here. So it's just 10,000 equals 6,000 times 1 and 1/15 will be 16/15 to the t. Right? So 1 is 1 being 15/15. And then let's solve this thing. So we're going to divide both sides by 6,000 first. 6,000s will cancel on the right, and then we know we can cancel some zeros out here, otherwise create recalculates. It becomes 10/6, which both divided by 2, so we can take that down to 5/3 is now equal to 16/15 to the t. And this is the place where now we can go ahead and take the natural log, common log of both sides. I'll use common log this time. It doesn't matter, you can do either one, but we have to introduce that logarithm so we can get that variable that's a power out in front, right? So the left-hand side is just going to stay log of 5/3 is equal then to t times log of 16/15. And that's what that property of logarithms, that power property of logarithm says. You can pull that power out in front of that logarithm, right? And then we're almost there. We can get t by itself. This is a product here, so we can go ahead and divide both sides by 16/15. And we'll do it to both sides. We get log of 16/15. And these can be typed in. Remember, these are the common log, which are just base 10. That's what our calculator works with here. So let's see if we can get this thing typed in here. Log of 5/3 divided by log of 16/15. This is great. We used all fractions here. There's no rounding error, no possibility of rounding something and getting some value that's just a little bit too far off. So that we end up finding that t is approximately 7.92. We'll round that. It says round to the nearest hour, so that actually takes us up to 8 hours. Okay, and again, we got some units there, so make sure you include the units with your answer, and there it is. All right, good luck on the assignment.